Hi, this is Mrs. LaBarbara. This is Physics Chapter 9, Current, Electricity, and Magnetism Video 10. Today's topic is electricity and magnetism connection. The objectives are no moving charges, hence electric current, can produce magnetic fields. To know what an electromagnet is. To know charges can be moved by magnetic fields. To understand how potential difference is induced by moving magnetic fields. First, current to produce magnetic field. So basically, this is showing a wire with the electrons is moving inside. So moving charges produce magnetic field. Electric current that are moving charges, and the electric current can cause magnetic field around it, just like magnet cause magnetic field. If I put a compass near this wire, you will see the needles will move. That is because there is magnetic field around this wire. The direction of the magnetic field is around it. Magnetic field lines wraps around the wire. You can find the direction using right-hand rule. That means you use your right hand, your thumb pointing to the direction of current. This animation shows the electron moves. So remember, the current is where the positive charge moves. So the current in this case would be pointing to the left. So if you have thumb points to the left, your four fingers will be curled around the direction. Is the same as this black lines. So that's the magnetic field lines. Electromagnets. So a conductive wire with a current flowing through it creates a magnetic field. However, the magnetic field of one wire is very small and does not have much strength, even though we can detect it. If we take a wire and coil it several times to form a long coiled piece of electrical wire, we would have a magnetic field much bigger and stronger when we turn on the current. Here is just a picture to show this, this nail is magnetized. A nail is attracting paper clips because there is magnetic field around this coil. So if an iron bar is placed through the center of the coiled wire, it would become a temporary magnet called an electromagnet, as long as the electric current flows through the wire. But if you stop it, then the nail is not magnetic anymore. So this is called electromagnet. Electromagnetic induction. Just as an electrical current induces a magnetic field, when magnet is moved in or out of the coil of a wire, or when electrical wire cuts across magnetic lines of the force, the magnetic force acting on the electrons and makes the electrons move. Since the electron move to one side, this will produce an induced potential difference. As a result, potential difference is the one provided by a battery. As a result, a current is generated. This process is called electromagnetic induction. Let's see what that means. So here is basically just wire you connect to the meter. If you just connect a wire to the meter, there's not going to be current because there is no battery. But if you put this magnet inside, move it in and out of this coil, you will see current will be produced in here. This is called the electromagnetic induction. Another way to induce is, here is a wire, a bar, you connect it, you move this wire, cutting the lines. Do you see the magnetic lines going from north to south? But you'll have to moving away, so it cuts lines. When it cuts the lines, it will produce a current. The current will be flowing in the wire. That's because there is a potential difference in this bar. But you have to move it away so to cut the wire. If you move from south to north pole or from north to south pole or move up and down, there's not current is going to be produced. in order to produce current, the wire you're moving has to cut the line. That's only one way to move it, so it cuts the line. A generator. So electromagnetic induction is the principle by which electric generator can make electricity. Through the use of magnets, a generator can convert mechanical energy to electrical energy. So first, for it to generate electricity, some of you probably have generators at home. A generator actually runs on gasoline. What that gasoline does is it converts chemical energy in the gasoline to mechanical energy. It will make this circle or rectangle move. This rectangle is metal bar. When the rectangle bar moves in this magnetic field, it cuts the line. Remember, when it cuts a line, it's produce electromagnetic potential difference, and that potential difference will make the electrons move. So that's how electricity is generated. So but how do you make this rectangle move? The energy is coming from the gasoline. Okay, so inside all the generators are heavy because there is a big magnet inside. So some electrical wire and a source of mechanical energy. That source of mechanical energy, most generators is run by gasoline, right? Mechanical energy moves the wire in the magnetic field of the magnet so that wire cuts through the magnetic lines of force. As a result, electric current is produced, because there is a potential difference is produced, like the battery is produced, kind of. So make the electrons move. So current is produced. That's how the current runs through your house. So a motor versus generator. Motor, on the other hand, changes the electric energy to mechanical energy. So that's what a motor does. So here is the motor. So motor runs on the battery. So this battery changes the mechanical energy changes the electrical energy into mechanical energy. So how does this wire move? In order to make the wire move, you'll have to have magnets. So all the cars has magnets. So when the electricity runs through these wires, and the wire is inside the magnets, what happened is the magnetic field will exert a force on the charges in the wire and make the wire move. So that is a motor. So motor is using electric energy converted into mechanical energy through the magnets. Now, on the other hand, a generator use the mechanical energy converted into electrical energy. So first is obviously the gas. Running on the gas is chemical energy changing to mechanical energy, and through mechanical energy in the magnets produce electricity. So motor and generator is like two sides of a coin. Let's take a look at this example. An accelerating particle that does not generate an electromagnetic wave, electromagnetic field, that means, is what kind of particle? We know all charged particles, moving charged particles, produce the electromagnetic field. So which particle is not charged? The particle that's not charged is a neutron. So only when neutron moves, doesn't matter if it's accelerating or not, it does not produce electromagnetic field. Here is another example. So which procedure will produce greatest induced potential difference in the conductor? So in order to produce difference, the wire has to cut the magnetic field lines. The field lines is from north to south in a vertical direction. So how can this wire move to cut the lines? Remember, in order to produce electricity or potential difference, the wire has to cut the lines. So in order for this wire to cut the lines, it has to move out of the screen or into the screen. not up and down and not left and right. So the answer is number 2. That's it for today. Thanks for watching. By the way, there are many videos on how generator works and how motor works. I highly suggest you to watch it.